Welcome to Do You Know, Chanel, a place to discover interesting facts, mysteries of the universe, and human knowledge. Imagine looking up at the night sky. The stars shimmer, scattered across a vast black expanse. For thousands of years, humanity has gazed upward, wondering, how big is the universe really? What lies beyond the faintest star? How far does this cosmic ocean stretch? The answer, as it turns out, is both mind-boggling and humbling. A testament to the boundless curiosity that drives us to explore our place in the cosmos. To begin understanding the scale of the universe, let's start close to home. Earth orbits the Sun at a comfortable distance of about 93 million miles, or 150 million kilometers, a distance we call one astronomical unit. That's already a number too big for most of us to truly grasp. But it's just the first step on our journey outward. Our Sun, brilliant and life-giving, is just one of roughly 100 billion stars in the Milky Way galaxy. The Milky Way itself is a sprawling spiral, its arms stretching out more than 100,000 light-years from end to end. A light-year, the distance light travels in a single year, is nearly 6 trillion miles, or about 9.5 trillion kilometers. So when we say the Milky Way is 100,000 light-years wide, we're talking about a width of nearly 600,000 trillion miles. But the Milky Way isn't alone. Peer deeper into the cosmos, and we discover that our galaxy is one of billions, perhaps even trillions, of galaxies, each with its own stars, planets, and mysteries. The observable universe, the part we can see and measure, stretches out to a distance of about 46.5 billion light-years in every direction from Earth. That means the full diameter of the observable universe is about 93 billion light-years. Let's pause for a moment and consider what that truly means. Light travels at the fastest speed in the universe, about 186,000 miles per second. Yet it would take a ray of light 93 billion years to cross from one side of the observable universe to the other. And remember, that's just the part we can see. The universe may be far larger, perhaps even infinite, extending beyond our horizon into realms forever out of reach. How did we come to estimate these staggering dimensions? The story begins with the speed of light and the nature of cosmic expansion. When we observe distant galaxies, we're seeing them as they were in the past. The farther away they are, the older the light we receive. Some galaxies are so remote that their light has traveled for billions of years to reach us, offering a glimpse into the early universe. But the universe isn't static. In 1929, astronomer Edwin Hubble discovered that galaxies are moving away from us, and the farther they are, the faster they recede. This observation led to the concept of the expanding universe, a cosmic balloon stretching in all directions. The implication is profound. If the universe is expanding, it must have had a beginning, a moment when all matter and energy were concentrated in a single, unimaginably hot and dense state. This moment is what we now call the Big Bang, estimated to have occurred about 13.8 billion years ago. You might expect then that the observable universe would have a radius of 13.8 billion light-years, the distance light has traveled since the Big Bang. But because space itself has been expanding, the most distant objects we can see are now much farther away than that. As the universe grows, so does the distance between galaxies, stretching the light as it travels. This is why the observable universe extends much farther than 13.8 billion light-years. Beyond the observable universe lies the unobservable, a realm whose size and nature we can only guess at. If the universe is finite, there's a limit. a cosmic frontier beyond which there's simply nothing. If it's infinite, then no matter how far you travel, there's always more space, more stars, more mysteries. Current evidence suggests the universe is flat on large scales, which hints at the possibility of infinity, but we can't be sure. Our observations are limited by the speed of light and the age of the universe. But size isn't just about distance, it's also about number and scale. Within the observable universe, scientists estimate there are about 2 trillion galaxies, each containing hundreds of billions of stars. Multiply that by the number of planets, moons, asteroids, and comets, and the numbers quickly become incomprehensible. There are more stars in the universe than grains of sand on all the beaches of Earth. Let's bring this down to something tangible. Imagine shrinking the solar system down so that the sun is the size of a basketball. On this scale, Earth would be a tiny speck, about the size of a pinhead, orbiting about 100 feet away. The nearest star, Proxima Centauri, would be another basketball more than 4,000 miles away. Our galaxy, with its hundreds of billions of stars, would stretch across continents. And the observable universe, its edge would be billions of times farther, receding into a distance we cannot meaningfully represent. What about the smallest scales? The universe is vast, but it's also composed of the tiniest building blocks, atoms, protons, quarks, structures so small they defy our everyday intuition. The cosmos spans an extraordinary range, from subatomic particles to superclusters of galaxies, from the infinitesimal to the infinite. Even the structure of the universe is awe-inspiring in its scale. Galaxies are not scattered randomly, but are woven into a vast cosmic web, with filaments of galaxies stretching like strands across empty voids. These filaments can be hundreds of millions of light-years long, connecting clusters of galaxies in a grand interconnected tapestry, and yet, for all its vastness, most of the universe is empty. The distance between stars is so great that the odds of them ever colliding are vanishingly small. The space between galaxies is even more immense, a dark, silent gulf, where only the faint glow of distant galaxies breaks the emptiness. What does it mean for us, living on a small planet, orbiting an ordinary star in a typical galaxy? The sheer scale of the universe might seem to suggest insignificance, but it also offers a different perspective. We are part of a grand story, participants in a cosmos that has evolved over billions of years. The atoms in our bodies were forged in the hearts of ancient stars, scattered across space and reassembled into life. In a very real sense, we are the universe made conscious, able to wonder at its own immensity. The question of how big the universe is also touches on the limits of our knowledge. Our understanding is bounded by what we can observe, by the tools we have built, and the theories we can test. New discoveries continually push back the frontiers, revealing structures and phenomena we never imagined. Dark matter, dark energy. These mysterious components make up most of the universe, yet we cannot see or touch them directly. Their presence is inferred from the way galaxies move, the way light bends, the way the universe expands. Perhaps the greatest lesson of all is humility. The universe is not only bigger than we imagine, it's bigger than we can imagine. Each advance in astronomy, each new telescope and probe, reveals another layer of complexity and wonder. We are compelled to ask deeper questions, to look farther, to seek understanding in the face of the infinite. And yet, in some ways, the universe is also intimate. The same laws of physics that govern the motion of galaxies also shape the chemistry of life. The patterns we see in the spiral arms of galaxies echo in the growth of plants, the formation of hurricanes, the rhythms of our own hearts. There is unity in the diversity, a profound connection that binds everything together. So how big is the universe really? It is vast beyond measure, stretching across distances and timescales that dwarf our imagination. It encompasses everything we know and everything we might one day discover. It is a place of endless possibility, a canvas on which the story of existence is painted in stars and galaxies, in atoms and energy. As we gaze into the night sky, let us remember that we are both small and significant. A brief moment in the unfolding tale of the cosmos, yet capable of wonder, of curiosity, of understanding. The universe invites us to explore, to ask questions, to seek meaning. Its size is not a barrier, but a challenge, a reminder that there is always more to discover, more to learn, more to dream, and perhaps that is the greatest gift of all. In our quest to grasp the size of the universe, we also discover the boundless capacity of the human spirit to reach for the stars, love space and science. Then hit that subscribe button and turn on the bell so you never miss a cosmic update from us.